So we have three speakers for our next session, for our next panel. John McQuaid is Photo Archive Lead at the Frick Art Reference Library. Vardan Papyan is an assistant professor in the Department of Mathematics at the University of Toronto, cross-appointed with the Department of Computer Science. And XY Han is a PhD student in the Department of Operations, Research and Information Engineering at Cornell. So their title is AI and the Photo Archive. In this talk, they will be describing a collaborative project between art historians and staff at the Frick and researchers at Cornell, Stanford, and the University of Toronto to develop an algorithm that will apply a local classification system based on visual elements to the library's digitized photo archive. So I will turn over to you guys. Thank you.
Great. Thank you, Christopher. Thank you, Lise. Thank you, Katie, and the AEOLIAN project. So much goes into producing a workshop like this. So first, short history and the problem we're facing. The Frick Art Reference Library was founded in 1920 by Helen Clay Frick, the daughter of the industrialist Henry Clay Frick. And after a trip to Europe, where she toured the Courtauld Photo Archive.
Wait, John, are you in presentation mode? Or
yes. Oh, thank you. I'll keep it in read mode.
Okay.
Always a technical glitch. After the trip to Europe, where she toured the Courtauld and recognized its value, she decided to find a similar research institution in New York because books and articles at this time were not often illustrated. So having a collection of photographs was immensely helpful to scholars. The archive was originally housed in the bowling alley located in the basement of the Frick Mansion, seen here. And from these humble beginnings, the Photo Archive now has over 1.2 million reproductions of works of art, of which almost 400,000 have been digitized and are available at digitalcollections.frick.org. To organize this rapidly growing collection, we developed an in-house classification system based on National School of the Artist and subject matter of the work of art. The classification number is seen on the upper right of the back of the mounted photograph. In this case, it is 221-1Y. The first digit 2 is for the British school. Each major school has a number. 1 is American, 5 is French, for example. 21 is for male portraits. 22 is female portraits. 17 is landscapes. 36 is animals. And numbers after the dash add further specifications. In this case, 1 is full length, but 2 is equestrian, 3 is 3/4 length. And this can become as specific as 21-19, which is portraits, men, without hands, with hats, head to left. And due to our detailed cataloging, we have over 500 classifications in total. This is not only useful in analog form, as our digital collection site has a facet for one to search based on these classification headings. And as of March 2020, all of our classified paintings and drawings have been digitized and cataloged. However, the majority of the photo archive has not received specific classification numbers. From the very first years, photo archive staff recognized that a backlog was developing and released to the public photographs without classification numbers. As we move forward to catalog and digitize these photographs, we have found that assigning one of our 500 classification headings to these loose photographs is usually the slowest point in the cataloging process. With a tool to be outlined by Vardan and XY, we on the library level look forward to using AI to assign classification headings to greatly increase our output and allow photo archivists to spend time and energy on other projects. And with that, I will hand it over to Vardan.
So in our project, we chose to focus on the annotation of the digitized images in the Frick Photo Archive, as John just said, with their corresponding labels, as shown here. As a demonstration of the challenge in this task, we have here on the left an actual image of a lady from the photo archive, and on the right, a non-exhaustive list of labels from the photo archive that might apply to this image. For a human annotator, thinking about whether each one of these labels would apply would take quite a bit of time, especially when this must be done on millions of images in the photo archive. Take a moment and think to yourself, which of these labels apply to the image? A moment has passed. The labels that apply are the following. When we met with the Freak, our first thought was that there is a growing trend in machine learning to use artificial intelligence for the amplification of human effort. We've seen this trend in medicine, in industry, and also in science, where there are many examples. Here, for example, you see some of the examples in biology and physics. And we decided to do similar augmentation of human effort for digital art cataloging. And specifically what we've done was to train a deep neural network on around 40,000 images from the Freak photo archive that have already been manually and laboriously labeled by the museum staff. And for more technical members of the audience, our solution modified the resonant 152 architecture, which was pre-trained on the well-known ImageNet dataset. And we modified this architecture with a custom last layer classifier that was able to incorporate the tree-like syntax of the free classification system. Take it away, XY.
Right. So, and around this network and to validate its result, we designed an app using the Zooniverse interface, which many of you may be familiar with, for validating the AI's predictions. We call this the Henry Clay Tinder because in this app, the network predictions is shown in this simple interface here with the network's predictions on top. So this is one of the Frick's 500 possible label combinations. If the museum staff member believes this is correct, they swipe right. If they believe it's incorrect, they would swipe left, and we remember this result to be collected later. So either it will be verified or, I guess, further processed. And this app, of course, has both a mobile and internet interface, which makes it easy to use from any device. And this whole pipeline relies on a series of well-tested machine learning stacks and solutions where you see, for example, the well-known PyTorch framework with which we trained the network. It's piped on the internet through the ImageKit framework for annotating and editing the images. Then it's piped to Zooniverse. And finally, it's piped, what the end user really sees is this app. And between August 2019 to 2020, we applied the network with this app to a collection of 8,661 images that was never shown to the network before, unlabeled. And on the bottom, you see the results of what comes out of the app. You have the image name, what the network predictions predicted, whether the staff member or intern actually swipe left or right, who that person was, and also expert and non-expert literally means intern or staff member. And the results were quite encouraging, around 67%, so almost exactly 2/3 of the images were completely in agreement with what the staff member or intern would have annotated the image with in the first place. So you see each label has individual components, and this means that they agreed with every single component. And even among the disagreements, a subset of which is shown here, you see that the disagreement is usually only on one particular component, and the majority of each label is correct. So to summarize this project, the whole machine learning, I guess, revolution, if you want to call it that, is amplifying human effort in domains that are more, I guess, visible, such as science, medicine, industry. And in this sense, it allows us to think, why not this photo archive digitization process? And this fits into the whole process that we call curatorial amplification, where the metadata that needs to be digitized, it's generated automatically, but we still have a person on the other end who is checking all the AI's results. So we're not replacing the person, we're just making them more productive. And we believe there's a lot of room for development in this interaction between digital art history and AI research. And it's a very, I guess, productive field that could develop. So thank you, and we'll be happy to chat or answer any questions in the Q&A later. Thanks.
Thank you, team. That was again another really interesting presentation.